The next speaker is Josip Stuhli. He will be talking about scaling from 0 to 20 million users.
Thank you. Okay, so my name is Josip. I work at a company called SofaScore. I'm the CTO there. And basically what we do is an application that delivers sport results, statistics to end users. And the project kind of grew a lot over the course of its history. And I'm going to talk about some of the issues that we had and how we solved them, kind of do's and don'ts of scaling. So just to give you an idea of how big the project is, we have 20 million monthly active users that generate 600 plus terabytes of traffic, and they do more than 180 billion requests each month. We take a lot of time to kind of really provide our users with a great user experience, which is reflected in the grade that we have on Google App Store and Play Store. And these are the technologies that we use, so a lot of stuff. The backend itself is written in PHP, which kind of amuses a lot of people, but you can do it if you want to. This is our growth. So it really caught us by surprise, and we had to solve a lot of problems kind of on the go. But we managed to get where we are now. As most companies, we started with just one server, and it actually was a shared server in the beginning, and it was running, as most sites did at that time, VHM and cPanel. We actually did not manage hosting. It was just a company that did everything for us. The reason why they had this is just the simplicity. They would just install VHM and click around, which obviously wasn't the greatest, but it worked, kind of. And our office was just two guys doing stuff in a really small apartment. But things kind of started getting slow because more and more users would come. And I'm not even talking about a lot of users. So 1,000 users would come at the same time and the site would crash. And we got a suggestion from our hosting provider that we should just put Nginx in front of Apache and PHP. Why? Because Nginx was better at serving static content. And it worked, obviously, but just not to the level that we were expecting. So the next obvious thing that one would do when presented with a problem like this is just to separate to two servers. You would get a web server and a database. And this, of course, helped a lot. We could handle more users. It would not crash on 1,000 users. And the benefit also is that you get a kind of a separation of concerns. You can see which resources are being used on different machines, and you can scale accordingly. And since PHP isn't really memory hungry, we had the opportunity to use that remaining memory to install memcache and to start using the cache on a project. And this is something that really, really helped a lot. So the cache was really simple. When a response would be rendered, it was just saved to memcache. So a full page cache, really simple, but it did help a lot. But you have a problem called the thundering herd problem, which is what happens when something is no longer in the cache. Then all of the requests that come to the backend really have to be calculated and then stored to the cache. If your calculations lasts for some time, let's say a second or two, and you have a lot of users, then all of the other requests won't actually hit the cache, but will calculate the same thing over and over again. And this is what crashes your server. And to combat, this is not an easy problem to solve, right? Because you have to have locking, you have to queue connections, you have to do a lot of stuff which you cannot do with PHP. Fortunately, we knew exactly how our users were using the app, and since it's a sports app, you actually get users, you really know where they're going to come because they are looking at the stuff that's currently playing. So we got an idea where we could just take the memcache and have a worker that would pre-calculate everything in the span of minus and plus 2 hours. And this is actually how we solved this issue at that time. This is due to the fact that we really knew how the site was being used. So that's a really important thing to note. You have to know how your users are interacting with your application. So at this point, we could handle a couple of thousand users hitting our servers, which to us was a really, really big number, although now it's small. And we have a really interesting use case where when there's a big match coming, so 15 minutes before, we get a certain number of users before the game starts. And when the game starts, that number doubles. So it really has a big impact on the server. And after those, when the game starts, it's also climbing a little bit and then drops down. And when you have issues, we were couple of times what happened to us was the server would crash and we were just hoping that people would go away so that those most persistent would keep going to the site and actually seeing something. So that was our how we solved issues, right? We would just wait. And then a big event happened. So this is El Clásico, two of the biggest teams in the world when they play each other. And of course, 15 minutes before, we saw that the server was kind of on the verge of dying. And we knew that we have 15 minutes to double the capacity, which is, of course, impossible if you're using a dedicated machine. So we were kind of thinking, what could we do to survive this? Because it's only a single event, so it's not rocket science. And we kind of got to the idea that PHP, we have the cache, right? But the cache still has to load PHP, bootstrap the framework, get stuff from the cache, and then display it to the user. But Nginx is really fast with static content. So we decided to use Nginx to our advantage. What we did was we got to the idea where if we would to save the page, and then just do a rule, if you go to this particular page, return the static content. So we did just that. We got the file, save as, uploaded via FTP, of course, and then wrote a rule. If you go to El Clásico, then just return this static content. And it worked great. But, of course, since this was static content, it did not update. So what we ended up doing was looking at the match and then manually updating the score and then uploading it as fast as possible. So I would not recommend you doing this, but it worked in our case. And that's something that gave us an idea on what to do next. So if you have cache that's not in PHP or any other language for that matter, if you have some specialized software, it can really make a big, big difference in how you can scale the system. And right about that time, cloud was all the rage, and we really did have a great use case for it because the spikes are enormous. So auto-scaling in cloud was something that we would really have a benefit from. And of course, the only player at the time that was known was Amazon. So we decided to take a leap and move from a data center to Amazon, to cloud. We, of course, moved away from our hosting provider, got rid of VMGM and cPanel because it makes no sense to use them. And we relied only on open source and free technologies. So we just bundled Nginx and PHP FPM. And since we knew how important cache is in our case, we found this great piece of software that we use today. It's something that enables us to reduce our cost by 95%, maybe more, so a lot. It's basically what it is. It's a reverse proxy that caches your content, and it's extremely fast. So the average response latency is not in milliseconds, but in nanoseconds. So an amazing piece of software that's free and open source. So one machine can handle 15,000 requests per second with ease on commodity hardware. And also what it does request coalescing. So that's the thing I was talking about before. you solve the thundering herd problem, because what happens is Varnish will just queue all of the connections for you, put just one single request to your backend. When it gets the response, it will give that response to all of the users that are waiting. So only one response will ever hit your backend, which reduces your costs significantly. And also the system is really, really fast. We bundled everything in an Amazon machine image, and we set up an auto-scaling group, as one does, pretty standard stuff. And it worked really great, because we were able to get to 3,000 users at the same time without any hiccups on the system. We were using MySQL at the time and decided to try something new because we were young and naive. So we installed MongoDB. It worked great because you get a lot of free stuff out of the box. You get replication, you get master election, and it's really fast. It worked great for us for a time. We also added queues with Beanstalk. This is a must-have if you want to have a scalable system. Queue everything that is slow. Everything that doesn't need to happen in real time has to be put in a queue. And this is something that enables us to really absorb a lot of the users that keep hitting our backends. MongoDB worked great until it didn't, as it so often is. So we had issues with replication, where some stuff just wouldn't be replicated. You wouldn't know it. We had issues with data types. So an integer can be a long or a short integer, and you don't know it until you have issues, which is something that happened to us. And it's not a fun thing to solve. It's also difficult to analyze data, and that's what we do. We analyze sports data. So kind of completely missed the right tool for the right job part. And also locking. So MongoDB at that time had locking on collections, which means when you write something to a table that's really big, you cannot read from it at the same time. So the performance kind of kept degrading a lot. And also we had inconsistencies due to it being a document database. I'm not saying it's wrong, it was just completely wrong for our use case. So we started to look at how we could solve this issue, replace MongoDB, but kind of get a database that is really good for our use case. We have a lot of updates in a short period of time. So after searching around, we got to Postgres, which is an amazing piece of software. Or also, it's open source and free. They have a lot of years in front of them and before them, and it's working really well. After doing some searching, the reason why we chose Postgres is it's open source, which was important to us. It has great performance. It has advanced SQL abilities, which means that they implement all of the SQL stuff really fast, and you can utilize really cool stuff before other databases. And the most important thing for us, it has minimal locking. If you haven't heard about the term multi-version concurrency control, you can look it up. It basically means you can do writes and reads at the same time and it won't break, which was really important to us because we have a lot of updates. When a lot of games are playing at the same time, we want your users to read at the same time that data is being written to the database. So just to give you a feeling on how good the database is, we can do 1 million queries per second, selects, simple selects, and 90,000 transactions per second. One transaction is select, 3 updates, and an insert. So a lot. We can do 500,000 operations that change the state of the database. And this is just on one server. It is a beefy server, but just one server. We also have a replica, which means that the number of queries per second is actually double this capacity. So we decided that Postgres is the way to go, but we needed to change from MongoDB to Postgres in real time while everything is running. So we couldn't afford ourselves to have any downtime. And that's kind of how it looked. So you would want to change the tires on your car while the car is running, and you have no idea on how to do that. So we were kind of brainstorming how we could do that and came up with a migration plan. Now I would say this is crazy because we were young at that time. We didn't know what can go wrong, so we were just really confident that it will work right. The migration plan was really simple. So we would timestamp all of the collections in MongoDB. We would write a tool to transfer any modifications since the tool last ran to Postgres. We would just run it in a loop until the system was synchronized. And we expected it to work. So the tool was written in less than a week. We deployed it to a canary machine, which would just handle GET requests, just to see if the response was identical because we didn't know any better. It turned out to work okay, which was surprising. We checked for inconsistencies, saw that actually everything is as it should be. Then we did a blue-green deployment, and after we were confident that everything is working, we just killed MongoDB. And that's how we migrated, and I'm still surprised that it worked really well. So sometimes you just have to have the balls to do it. The pros and cons of this. So what we lost by going to Postgres was simple replication because Postgres doesn't have it in that way. Also, the configuration is really complex when compared to MongoDB, and you lose a leader election. But what we gained was stability, analytical power of a relational database, and also foreign keys, which then cover consistency. And after that, everything was on autopilot. It really was. We had no issues with infrastructure. The number of users just kept growing. So in June 2014, you can see on the little number in the back of the screen was almost 5,000 users came to the site. A couple of months later, 16,000 users, and everything kept working. So we could just focus on adding new stuff to the application. So this is how our day looked like. We would watch the game, drink some beer, and just look at the numbers. So we could focus on building a better product. So we got to working on more features. And then more features means more endpoints for the API to consume. And more endpoints means that your hit rate on your cache is lower. And also more users, they target different endpoints, which then all means that you have more servers, because we were on Amazon and we're doing autoscaling. So this might seem that it's a good idea to do. I mean, that you have no problems with it, but you have. Because we bundled our varnish, our cache layer, with our application. This was just done so it's easier to kind of build the image and to scale. But when you get more users, you get more machines. And more machines means that each machine has its own varnish cache, which means that the number of requests that goes to your backend really kind of grows with the number of servers, which is not optimal. So the way to solve this is just to put varnish in front of everything, which might seem obvious now. But at the time, we didn't really think about it. And this is something that works really well. But still, the backends will always receive 2 requests, which means that we are doing unnecessary calculations on our system. So the way to solve this and to just have 1 request due to request coalescing going to the backends, you can do something like this. So just put another machine that will then kind of act as a single source of truth. For those of you that are into system operations or DevOps or whatever, you can see the problem here because we have a single point of failure. And we were actually running this for a while in production, kind of, again, oblivious to the fact that everything can break at any single point in time. But when we got around to it, we decided that this is no longer acceptable for us. And mind you, this was like 7 years ago. So we were quite young then. The way to solve this is just to do URL sharding. So you have 2 layers, and if something is not in the cache, it will go to the second layer, and it will go to different machines based on the URL, which means for URL A, it will go to one machine, for B, it will go to another machine. And that way you can scale your system horizontally, so we can increase the cache for both layers without any issues. And this also means that only one single request will ever go to the backend, regardless of how many machines we have. So we could cache all of the things. We actually wrote and open sourced a software that enables us to really purge any URL with ease. So junior developers can write really efficient code, cache everything to a couple of days, even though something is changing by the second. And Amazon was working great, but also not but. We managed to get to 50K real-time users. But the issue with Amazon is they really charge you for the traffic a lot. And we had a lot of traffic. And that always translates to a lot of money. So the way to combat this was, since we already have a cache layer that's kind of separate from the application, we can do whatever we want with it, we decided to move it away from Amazon. And since the hit rate is more than 95%, we could just fetch something from Amazon, but keep the cache layer outside of it. Because dedicated machines are really cheap, and they have a lot of traffic associated with them. And by doing this, so we actually didn't change anything. We just moved the machines and changed a single IP. So it was really a simple thing to do. And that resulted in a 10x reduction in our bill for hosting, for the machines. And when you start to look at how much we are paying for the cloud, which, by the way, is great, but it's expensive, we started to think about what would happen if we would to migrate everything from the cloud back to the data center, since we now have experience in managing machines. So we actually decided to do that, to migrate everything from AWS and do it ourselves. So instead of an Amazon machine image, we were using Docker image. We also were running Docker containers. And instead of the load balancer, we were using Cloudflare, which would then load balance the requests for us. And with this system, we got to 100K real-time users without any issues. But then we started to kind of see that developers were struggling with deploying all of that to all of the machines, which was kind of a pain in the ass. So we switched to Docker Swarm because it was simple at the time. And it seemed like it's a good thing to have. Don't do it. It's obsolete. But it did help us for a while. We also have a really specific use case where we send out push notifications, and a lot of people come in a short period of time, and we do a DDoS on ourselves. So a lot of providers were actually having issues with us where they were blocking our real users because of the spikes. So we had to fly out to the US and talk with the guys from Cloudflare to kind of put special rules just for us so we would not trip their anti-DDoS protections. So that's something to keep in mind when you go to a certain scale. And after we tweaked those thresholds, we got to 230,000 real-time users. And then a month later to 300K. This was really impressive to us because we started with a system that would break on 1,000 users, and now we can handle 3,000 times more, 300 times more. In 1 month, that got to 400,000 real-time users. So what we do to kind of keep the quality of our system is we are running an APM. You have open source solutions or paid ones or free ones, it doesn't really matter. What you want to do is kind of check on your endpoints, see which endpoints are using the most CPU time, and then go and optimize that. So this is a real graph that we had where we optimized something and that really reduced the load in the system. Sometimes you cannot optimize because it already is the most optimized version. But in that case, if you increase the cache, then the number of requests that will go to your backend will drastically reduce. And that also has a great impact on your system and how much users it can handle. So we are running on dedicated machines, and probably some of you are asking yourselves, so what if the number of users exceeds the current capacity of the systems, and it cannot scale. So that's something that we solve really easily. Since we are in a data center that also has virtual machines, we just spin up virtual machines automatically. The cluster will then expand those machines, and it will handle the increased load. So we have a kind of a hybrid cloud where we have dedicated machines which are cheap, but we also have virtual machines that are spun up on demand. And with this, we got to 600,000 real-time users. Also, this is just a quick note. If any of you have any need for analytical kind of software, ClickHouse is the way to go. We use it to handle an absurd amount of data. So with ClickHouse, it's also an open source software. We have 852 terabytes of data for the user actions, and it's compressed to just 37 terabytes on the disk. We have more than 1 trillion rows with it can handle more than 1 million inserts per second. So a really crazy database that's really optimized for analytical work. We store HTTP logs there, and we have 6 billion logs per day with a 30-day retention. And we do it to kind of do analytics and anti-scraping for our system. And it just works. So we got to 800,000 in November 2019. The problem is we have our data centers in Europe, and the latency in other parts of the world is slow. So I kind of wrote an email to one of our moderators on the chat to give me a video of the application and how it behaves, just to see what's slow. And he replied, like, the app is working great. He's from New Zealand and moved to Australia. It's not slow, it's really great. It's the fastest application for sports there is. And then I saw this, which I didn't even know we had loaders in the application. So obviously we do. But it was slow, he just didn't perceive it because everything is slow in Australia. So, yeah. So what we did was kind of spin up more Varnish servers around the world. Again, since it's separate from the system, this is really easy to do. They all point to the same data centers in Europe. And we reduced the latency by eight times. So that's something that we do to kind of be better than the competition. And this always has a really positive impact in the number of users because we got to more than 1 million users at the same time. And also to replace Docker Swarm, we started using Kubernetes. If any of you are thinking of switching, don't. You have to be big enough because it's a really, you have to have a team to manage that. But if you do, Flanner for network, Nginx for ingress is what we're using, and Cloudflare Tunnel as a load balancer. Longform for storage, Helm for deployment, and it is data center aware, which is great because this can happen. Fortunately, it wasn't our data center, but whole data centers can catch fire. So that's something you should have. And last year, we got to 1.5 million users that are on the same time on the application. We also analyze our queries for Postgres. Postgres has a really great support to analyze the queries and what's slow. So we use that to also decrease our latency. And for real-time updates, so a pub-sub kind of work, we use NATS, which is also open source and free. It can handle an absurd amount of users. So on 3 machines, just normal, regular machines, we can handle 500,000 connections with ease. And you publish something like a score happened, and NATS will just propagate it to all of the users that are connected to it. And it will have a sub-millisecond refresh, so your users will see the results immediately. And this works great for not just live scores, but for any kind of problem that requires an instant information, such as chat or something like that. So just to recap and something for you to take home, if you can be stateless where possible, because that will enable you to scale easily. If you have anything that is slow, put it to a queue. monitor everything, and then optimize something. Premature optimization is the root of all evil. Know how your users interact with your application. That will help you to build a system that's really scalable. Cache, obviously, use it everywhere. And recognize the right tool for the job and change if necessary. Don't be afraid of change. It's something you must do in order for your system to kind of grow. Thank you. Questions?
Do you use other NoSQL or cache mechanisms databases to handle besides?
Yeah, so we don't use memcache anymore because we just have Varnish now. We don't cache anything else because there is no need. Varnish handles everything and it's really fast. We do use Redis, just not for cache. We use Elasticache, but not for cache.
Did you consider using Nginx cache?
Yeah, it's just not as good as Varnish for our use case because you have issues with invalidation. I mean, it's an amazing piece of software. For a simple use case, it's better than Varnish, that's for sure. No. We did. We don't anymore. Because now everything is in API and we have no need for that. Okay, thank you.